Hello students, welcome to Akash Live. I am a mathematics faculty and today we are going to cover up the quick solutions of AIATS, that is All India Akash Test Series for JEE Advanced 2019 test number 5A paper 2. Okay, so this particular paper is based on the complete syllabus of JEE Advanced, that is the complete syllabus of class 11th and class 12th, and the pattern of this paper is based on exact pattern of JEE Advanced 2015. Okay, so let us begin the solution discussion with question number 41, which says that lambda is the number of 7-letter words containing all the letters of the word again, such that all vowels are taken in such a way that no two vowels are together and consonants can be repeated as many times as we need. Then lambda upon 60 is. So students, we have 5 letters over here, A, G, A, I, N. Vowels are to be used only once and the consonants can be repeated. What are the vowels? Vowels are A, I, and consonants are G and N. So students, we have to form a 7-letter word where consonants can be repeated and vowels are to be kept such that no two vowels are together. So let us consider all the possible cases over here. The first case is A, I, G, N, G, N. Second case is A, I, G, N, G, G. And the last case is A, I, G, N, N, N. So I have to take 2 extra letters over there because I have to use all the letters of this word. Okay. So let us consider the number of possible cases in the first part. Over here I have total 7 digits, but consonants are to be arranged first. So we have 4 factorial upon 2 factorial 2 factorial because 2 G's are alike and 2 N's are alike. Now 4 letters are being placed. We have 5 gaps in between them. So we'll select 3 gaps for the vowels and multiply by the number of possible arrangement of the vowels amongst themselves, that is 3 factorial upon 2 factorial. We can obviously see that second case and third case, the number of ways will be same. So let us multiply by 2 into the number of ways of this case, that is 4 factorial upon 3 factorial. In the first case, 3 G's are alike. In the second case, 3 N's are alike. Okay. Multiplied by again 5C3 into 3 factorial by 2 factorial. So we have 5C3 into 3 factorial by 2 factorial common. That is 10 into 3, 30 is common. Over here I have 4 factorial upon 2 factorial, that is 24 upon 4, that is 6. Over here I have 2 into 4, that is 8. That is 420. So number of total words that can be formed is lambda. What is lambda by 60? 420 by 60. The answer of this question is 7. Okay. We have to answer in single integer type. Then 7 is the correct answer. Let us move on to 42. Question number 42 says that if the equation x power 4 minus 4x cube plus ax square plus bx plus 1 equals 0 has 4 positive roots, then the value of a plus b plus 2 is equal to. Students, whenever equation has positive roots, always think about AMGM inequality. Okay, so that is the hint. So we have x power 4 minus 4x cube plus ax square plus bx plus 1 equals 0. Let the roots be alpha, beta, gamma, lambda. So what is the sum of roots? Alpha plus beta plus gamma plus lambda. That is minus time coefficient of x cube divided by the leading coefficient, that is equal to 4. So from here I have alpha plus beta plus gamma plus lambda whole divided by 4 equals to 1. That means AM of the 4 roots is 1. Let us talk about GM. The product of all the 4 roots, alpha, beta, gamma, lambda, is equal to the constant term divided by x power 4 coefficient, so 1. That means alpha, beta, gamma, lambda raised to the power 1 by 4 is equal to 1, which gives me AM is equal to GM. For the positive roots, we have alpha, beta, gamma, lambda. That means if AM equal to GM, they all 4 are equal. Okay. So if all 4 are equal, alpha plus beta plus gamma plus lambda will give you 4 alpha equal to 4 and you will get alpha equal to 1. So that means alpha equals, beta equals, gamma equals, lambda equals 1. So that means if all 4 roots are given, we know that the equation will be x minus 1 whole raised to the power 4 equals to 0. So by expansion of binomial theorem, we have x power 4 minus 4x cube plus 6x square minus 4x plus 1 equals 0. So by comparing the coefficients of the two equations or by equating two equations, we can say that A equals 6, B equals minus 4. What is A plus B plus 2? It is 2 plus 2, that is 4. So 4 is the correct answer for question number 42. Let us move on to 43. Question number 43 says that if the equation x cube plus 2x square plus x plus 6 equals 0 has only one real root alpha, then what is the value of modulus of greatest integer value of alpha? Okay. So students, we have an equation. Let us analyze it through function fx, that is x cube plus 2x square plus x plus 6. So let us consider f dash x. There will be 3x square plus 4x plus 1. If f dash x to be put it equal to 0, we have 3x plus 1 into x plus 1 equals to 0. That means x equals minus 1 and x equals minus 1 by 3 are 2 points of extremum for fx, and since it has only one real root, I must ensure that f of minus 1 into f of minus 1 by 3 is positive, and that is true. F of minus 1 is also positive, f of minus 1 by 3 is also positive. Okay, so students, let us draw a rough graph of this particular function and try to analyze the roots from there. So from minus infinity to minus 1, the graph is increasing. From minus 1 to minus 1 by 3, the graph is decreasing. And then again it is increasing. Minus 1 by 3. Obviously, the root, real root alpha, will come before minus 1. So we have to find out two consecutive integers such that f of k into f of k plus 1 is negative. So we have f of minus 1 being positive. So f of minus 2, let us have a look at the value. Minus 8 plus 8, that is 4. F of minus 3, that will be minus 27 plus 18 minus 9. Minus 9 minus 3 is minus 12, so minus 6. So clearly, f of minus 2 into f of minus 3 has opposite sign. So the product is negative. So we have alpha belonging to minus 3 to minus 2. And the greatest integer value of alpha will be minus 3. And the modulus of greatest integer value of alpha will be equal to 3 simply. Okay. So we have the answer. 43 has the answer 3. Let us move on to 44. Question number 44 says that the distance between the rectices of the conic mod of z minus root 2 plus modulus of z plus root 2 iota equals 4. So students, mod of z minus z1 plus mod of z minus z2, sum of distances of z from two fixed points z1 and z2 equal to some constant is an ellipse if the distance between these 2 points is less than 4. Okay, so distance between these 2 points is 2. So definitely it is an ellipse. The distance between 2 points z1 and z2 is the focal distance, that is 2 AE. So 2 AE value is 2. Clearly, the value on the right hand side, sum of distances is 2A. So it is 4. From here you get eccentricity is equal to 1 by 2. What is the distance between directrices? Distance between the directrices is 2A upon E. So 2A upon E will give you value 8. Okay. So 8 is the answer of this question. This particular question is simply based on the property that if we shift the ellipse or we tilt the ellipse, the distances between 2 points or the distances between 2 lines does not change. A very, very simple concept. Okay. So let us move on to question number 45. Question 45 says that if alpha and beta are the roots of the equation, limit k tends to infinity, cos inverse of sine of tan inverse of root kx upon root of kx square minus 3kx plus k minus 1 minus x equals pi by 6. Then what is the value of the product of roots alpha into beta? Let us shift the functions because the limit is already given to be finite. So limit cos inverse will be shifted on the right hand side, it will become cos. So cos pi by 6 will be root 3 by 2. Then sine inverse root 3 by 2 will be pi by 3 and tan of pi by 3 will be root 3. So it is very clear that limit k tends to infinity, root kx upon root kx square minus 3kx plus k minus 1 minus x is equal to root 3. Students, the limit is on k, it is not on x. So whatever is the power of k in the numerator, which is 1 by 2, and the power of k in the denominator is again 1 by 2, the coefficient of the powers of 1 by 2 from numerator upon 1 by 2 in the denominator will be my answer. So the answer is root x upon root of x square minus 3x plus 1. It is the coefficient of k, okay, because the limit was on k, is equal to root 3. So we have x is equal to 3x square minus 9x plus 3, which gives you 3x square minus tan x plus 3 equals 0, which give you the product of roots alpha beta equals 1. Alpha beta are the roots of this equation, which is the equation x. Okay, the answer of this question is 1. Let us move on to 46. Question number 46 says that if the area bounded by the curves y equal to x square plus x minus 2 and y equals to x is lambda in square units, then what is the value of lambda plus 1 greatest integer? So we have y equal to x square plus x minus 2 and y equals to x. Let us solve them simultaneously. X square plus x minus 2 equals 2x. So x square minus x minus 2 equals 0. That is x minus 2 into x plus 1 equals 0. That is x equal to minus 1 and x equals 2. Simply the area is integration minus 1 to 2. Upper curve is line, lower curve is parabola. So 2x minus x square plus x minus 2 dx. Minus 1 to 2 minus x square plus x plus 2 dx. This value will come out to be equal to 9 by 2. So what is the greatest integer of lambda plus 1? Which is the greatest integer of 11 by 2, and that is obviously equal to 5. So the answer of this question is 5. Okay, let us move on to 47. Question number 47 says that consider a function y equals fx whose differential equation is given by f double dash x plus f dash x plus f square x plus 9 equals x square. If p is a point of local maxima of the curve y equals fx and p also lies on the curve x square minus y square equals a square, then what is the maximum integral value of a? Students, the differential equation satisfying the curve y equal to fx is y double dash plus y dash plus y square plus 9 equals x square. P is a point of local maxima. At point P, it is a point of local extremum, that is why y dash is 0. It is a point of local maxima, that means y double dash is negative. So we have from this equation, let us say equation number 1. So 1 implies y double dash plus 0 plus y square plus 9 equals x square. So y double dash equals x square minus y square minus 9, and that is negative. So x square minus y square minus 9 is less than 0. X square minus y square less than 9. And clearly P also lies on the curve x square minus y square equals a square. So x square minus y square equals a square less than 9. A belongs to minus 3 to 3. The greatest possible integral value of a, definitely the answer is 2. Okay, because the integers minus 3 and 3 have open brackets over there. So 2 is the answer. Let us move on to 48. Question number 48 says that points OAB are shown in the figure where OA equals 2AB. Let A be the centroid of the triangle whose orthocenter and circumcenter are 2, 4 and 7 by 2, 5 by 2 respectively. If an insect start moving from point O, 0, 0, that is the origin, along the straight line in a zigzag way as shown below, and terminates ultimately at the point B, that is alpha, beta, then what is the value of alpha plus beta? Students, we have the point A as the centroid of the triangle having orthocenter as 2, 4 and circumcenter as 7 by 2, 5 by 2. By the property of circumcenter, orthocenter and centroid, I have H is equal to 3G minus 2O. And G is point A over here, where G denotes the centroid. Okay, so G is H plus 2O by 3. From here you get the coordinates of point A as 3, 3. So if point A is 3, 3, which was very clear because it is lying on the line y equals x, it is making an angle of 45 degrees in the anti-clockwise sense with positive direction of x-axis. Very clear. This angle is 90 degrees as shown OAB. So this distance is very clear. OA distance is 3 root 2. The question you can conclude that AB distance is 3 by root 2. By using the parametric form, the coordinates of point B can be written as x1 plus r cos theta. So x1 is 3, r is 3 by root 2, that is the distance AB. Cos theta is cos of minus 45, so 1 by root 2, comma, y1 plus r sin theta. So 3 plus r is 3 by root 2 into minus 1 by root 2. The coordinates are 3 plus 3 by 2 and 3 minus 3 by 2. So 3 plus 3 by 2 will give you 9 by 2 and this will give you 3 by 2. These are the values of alpha and beta. What is alpha plus beta? Clearly alpha plus beta is equal to 6. So 6 is the answer for question number 48. Let us move on to the next section, which contains multiple correct type problems. So moving on to the next section, we have question number 49, which says that let L be equal to limit n tends to infinity, the definite integral from a to infinity, n dx upon 1 plus n square x square, where a belongs to real, then L can be. Students, let us first of all simplify the integral, which is integration from a to infinity, n dx upon 1 plus n square x square. So dividing by x square in the numerator as well as denominator, I have 1 upon n dx upon x square plus 1 by n whole square, a to infinity. The integration is with respect to x, so 1 by n is common. I have 1 by n into tan inverse of x upon 1 by n into 1 upon 1 by n. That is the integration of dx upon x square plus a square. 1 upon a tan inverse x by a. The limits are from a to infinity. Now 1 by n getting cancelled. I have tan inverse nx from a to infinity. And tan inverse infinity is obviously pi by 2 minus tan inverse of an. Now students, again we have just evaluated the definite integral. L is limit n tends to infinity, pi by 2 minus tan inverse of an. That is the simplified value of the definite integral. Fine. So L can take 3 possible values. If a is 0, definitely the answer is pi by 2. If a is 0. If a is positive, as n tends to infinity, pi by 2 minus pi by 2, 0. So if a is positive. On the other hand, if a is negative, pi by 2 minus tan inverse minus infinity, that means pi by 2 minus of minus pi by 2. That is pi. So we have 3 possible values for the given expression L. That is 0, pi by 2 and pi. So 0, pi by 2 and pi. The answer is A, B and C. Okay. Let us move on to next question, that is 50.